wasting any time, let's read it and try to solve it. How many integer solutions are possible for x minus 1 raised to the power log of x base 10 whole squared minus log x squared base 10, that is equals to x minus 1 whole cube? Now, obviously, the first thing that should come to your mind is there is some amount of algebra that you need to do. Basically, if you have solved enough logarithms, you will realize that the only way, actually not the only way, but the way that I like to separate out the logarithms in its basically prime form. It helps me visualize the terms a little better. So basically, now using the property of logarithm, taking the exponent to the right of it, so I can write it like this. Okay, that is equals to 3. Now this is very easy. The next point is, however, also very easy, in which you are just going to take the log x base 10 common throughout. When you do that, you will be left with one term log x base 10 minus 2, that is equals 3. Now that's it. If you have been able to reach thus far, the problem is almost solved. Understand this for a fact that now what I am left with is two terms, basically this term multiplied by another term that is equals to a k. Now k happens to be a prime number. Okay, prime number, basically this one is a prime number, 3 is a prime number which only has the possibility. So a can be 1 or 3 or 3 or 1. So there are only two possible cases. So this is case 1 and there is another case 2. Now there you can ask me, sir, what about minus 1, minus 3, minus 3, minus 1? Obviously, I'm not taking those negative values because log is not defined for negative values. So that way, I'm not taking that. Okay, now let's just use the cases one by one and try to arrive at an answer. So let's apply for this one, case number 1. So I'll do it over there only. So I'm doing it like a DILR caselet. Anyways, so log x base 10 equals 1. I'll directly, so once I'll write it, after that I'll just directly do it. That is equals to 1. When I transpose this log 10 to the RHS, x will be left as 10 to the power 1. So x can be written as 10. What about this term? This term will be equal to 3, right? So this is going to be log x base 10 minus 2, that is equal to 3. Now obviously x will be, when you transpose 5, x will be 10 raised to the power 5. So there is a possibility that x could be 10 or x could be 10 raised to the power 5. Great. What about the case number 2? Now I would like to do that orally. You can also do it orally. It's not very difficult. Basically this is equal to 3. So log x base 10 is equal to 3. X will be 10 raised to the power 3. So you can directly write that thing. The next thing, however, is log x base 10 minus 2, that is equals to 1 and not 3, because we are taking this case, right? 2 goes to the RHS, becomes 3. Again, when you look at it, x will be 10 raised to the power 3. Now there is a ambiguity. Some of the students have this ambiguity, sir, isn't there x is equal to 10, x equal to 10 to the 5, x equal to 10 to the 3? Answer should be more than 2, right? No, answer has to be 2 only, because in either of the cases, you're only getting maximum 2 values of x. Actually, one of the cases, you're only getting 1 value. But in one other case, you're getting 2 values. So maximum number of values for integer values for x is 2. And had there been any other case in which there were more than 2 values, let's say 3 values, 4 values, in that case, we could have gone for more than 2 for this particular question. Right now, we don't have that luxury, so we're only going to stick with 2. A decent level question, a very interesting question that has a capacity or a caliber to be asked in your aptitude tests. With that being said, I think this was a fairly decent question. Okay, thank you.